Again, hello everybody. Thank you very much for inviting me to talk a little bit more about technology across the board, but also to present to you really potential opportunities for the province of Quebec. Okay? All right. So my name is Hussam Haroun, and I'm the director for... Oh. Okay. Thank you very much. No problem. Okay. Perfect. Hello? How about now? Okay. It's better? Excellent. Okay. So my name is Hussam Haroun, and I'm the director for the automation program at Vineland Research Innovation Center. To get things going, we wanted to make it a bit collaborative. So what I would like to do is ask for the questions to be put on the board, please. Is it possible? Oh, perfect. So perfect. So I appreciate everybody's time. So the idea of this is to kind of get a feeling of what we think today in this room. What do we think the barriers for adopting technology? So I appreciate your participation in this. Let's see how it goes. Okay. Interesting. So the capital expense too high. This is a very consistent, probably across the board. The risk to uncertainty. So I hope in some of the presentation here, I'll be able to kind of walk you through some of the why. I'm sure some of you might know why, but also maybe opportunities to see how we can deal with those barriers. Okay. I think perfect. Oh, great. Can we move to the second question, please? I appreciate participating again. So what percentage of Quebec vegetable greenhouses area is taken up by tomato production? Do you think? Perfect. Okay. Yeah, so, I mean, no pun intended, tomato is the lowest hanging fruit in terms of the opportunity in most globally, but also especially in the province of Quebec. So we'll look at we'll cater the presentation in a way to look at the high value crops, but also other crops across the board. Okay? We'll put back the presentation if you don't mind. Thank you. Thank you very much, and thank you for participating on this part. Okay, so to get things going, let me tell you a little bit about my team and the program. So we were established about 5 years ago with a focus on trying to solve the labor challenge mainly in horticulture, right? 5 years ago, the province, in collaboration with the federal government, came together and created the automation program in Vineland with 3 major projects. We started in cucumber harvesting, looking at how do we automate cucumber harvesting. And then we looked at smart irrigation in floral greenhouses and mushroom harvesting as the third project. Those were the main core projects to get this challenge going and to help us understand how can we solve the labor challenge in the Canadian horticulture industry. So the program was developed with the intent as tackle the labor challenge, but try to understand the opportunities beyond the 5 years of the cluster. So if you, I don't know how many of you are familiar with this study that was done by CRAAQ? If you can put your hand if you're familiar with the study. Or not many, or many, probably. So what we did is we tried to understand what was already kind of looked at in the province here, and building on this, we built a complementary basic presentation that looked at beyond what was given to you beyond at that stage. So we're going to look at a bit more a roadmap analysis at both technologies that are readily available, some that are right now in the outlook of what could be available in the medium term, and others that could be a bit further. But it's always good to always plan for the future now, because we believe to automate a lot of the labor challenges that we have today across the board, there needs to be a bit of a pivot, not just on the sense of, put a robot in a greenhouse or put a machine in a greenhouse. We need to think about infrastructure. How do we do this together? How do we do it from an operations point of view? The payback takes into account the total cost of ownership. So to be able to understand the future from today, it's a good outlook for a lot of the growers and the industry as well. So there are exciting Quebec companies in the space who are either getting in or being involved in some part of it. So we are collaborating with some Quebec companies. We have Canova that is in the medical space. They're well known with their robotic arm, or we call it manipulator, right? And they're starting to build interest to look at how they can solve the challenge of harvesting with some of the technology that they have today, but they have to look at the business case to make it feasible for the long term for growers as well. We also have INO. This is a top-class research center in fiber optics, and they deal with cameras and vision. When it comes to automation, especially on the robotic side, how robots can see, identify the fruit like humans do, not even close. Cameras are the core component to what we do. And not the least, Nexus is a startup. So this space has a lot of startups, a lot of companies, a lot of startups, a lot of investment going to the space for startups. Nexus deals with weeding in the larger outdoor environments. The opportunity there for Nexus is to continue to validate their technology and make sure the business case works for the growers. So if you hear me talking a lot today about technology, I'm also going to talk a lot about the business case. What makes sense for the growers? What makes sense for the people that are delivering technology to the growers as well? So the key 4 questions that I'm looking to answer are, what are the regional considerations for Quebec? What technologies make sense for the province of Quebec? And what are those technologies in terms of what's available today, what could be available in the medium term, and what could be available in the future? Like I said, if we look at the future now, it could help us all together to be able to prepare for that future. And the third point is, what are the largest technological innovation approaching the market? So that's kind of the future outlook, but also from perspective of globally as well. And then what are the stages of technology maturity, and how should they be navigated? And that's key, because what you're going to face, and you probably are facing already, is that a lot of companies come to you with exciting technology, and they tell you these are going to solve all your problems. The challenge with that is that there's a lot more than just putting a technology in a greenhouse or in a farm environment. There's a lot of steps behind supporting it, delivering it, maintaining it, the life cycle of the technology, validating the business case. And there's a lot of support coming in from government as well as from local collaborations to help understand the benefit of that technology. So, regional considerations. So when we put together this presentation, we looked into the Quebec market, but we tried to understand how does that market look in terms of other regional markets. So understanding the farm size is key. Understanding the crop type and the value. What crops are we dealing with? And you've seen in one of the questions, tomatoes, is the largest crop that's grown in this province as well. But there's other crops as well, and also obviously the labor challenge, the access to the highly skilled labor, and the type of jobs that cannot be automated, that cannot be asking a machine to do it, or it's going to be a lot complex for machines to do. And the other part to this, which is very critical, is the cost and labor, so the business case, the business opportunity. So if you look at the 2 pie charts here, right, you look at Canada, in general from farm gate value. These stats are available in Stats Canada's website, right? You look at Canada in general. The three value crops: cucumbers, peppers, tomatoes. How they're split fairly equal at this stage to a certain level. But if you look at from a province point of view, right, from Quebec, tomatoes and cucumbers are the biggest, the largest available crops. But there's also a big pie of the cake is other. And one of the questions I was talking to some of my colleagues is, what is in the other part? The leafy greens and the other opportunities that exist in that space as well. And herbs is actually separated as well. But So looking at from the point of tomatoes and cucumbers, what we did is we tried to understand what technologies could add value to this and kind of give you guys something to think about for the near future. Now, another aspect is we looked at the size. Ontario is an outlier compared to the other provinces. And the way it's put in this presentation, it kind of looks quite funny, to be honest with you. But if you look at the other provinces, they are kind of within the same range. The other part to this is the size of the farms. So I've come to learn that there are a lot of small farms, and this is very common in most of Canada, but also there are larger farms as well. So there's this distribution where you have, if you have a set of technology or solution, most of the time, because of the business case, they can solve both at the same time. So you can have a piece of technology that can solve both small farms and large farms at the same time. So you're looking at two types of technologies or two sizes of technologies in this space. This is, for me, important because when we look at technology adoption and we look at the barriers of technology, we look at what are the driving forces. And we try to create a visual representation of this. Today, where we are, we understand, and you've seen from the first question, right? CAPEX, risk, they outweigh the opportunity of solving the challenges for labor and where technology is today, right? So that is a very important point, and we want to get to a level, even through the work that we're doing collaboratively with both government and industry, is to understand when can the scale step in the best interest of technology. And there are steps needed to do that. Some of the things that I want you to take away from this presentation today is technology validation, being able to validate the business cases of these technologies. Not just can they solve the problem, but do they make sense on the ROI as well? And also, how do we get them into the first trials for the farmers and the growers to see them and to validate them? And how can they be delivered to the industry? So if you look at the labor challenge, we all know this. I don't need to tell you the challenges that you have on labor, but the rising wages, decreased availability of local labor, the seasonal positions. So the other thing that we're also learning, a lot of the new generations don't want to actually do the repetitive tasks anymore. They want to get into more technical, more engineering roles, less hands-on. So there's a lot of generation of farms that are actually losing the next generation of people involved in their life. So this is a shift in population. So we have to look at that as well as part of the presentation. Another part to this is technology is actually improving. So we're seeing better cameras, better components to put those technologies together. They're doing things in a better way. And sometimes, actually, if you test them, they could do it better than humans. But they can't work better than humans. They can't work on the long term better than humans. So that's still a big shift and big challenge and the opportunity here. And we're seeing a lot of startups entering the market. So there's a lot of small companies. And how many of us can give these startups an opportunity? The other challenge with startups is that we also know the probability of startups surviving. So 1 in 10% of 10% actually make it. So there's a huge risk here for the growers and for the industry to adopt those new techs. Growth and consolidation. So another thing that we're seeing across the board is, there's a level of capital investment going in, but also there's consolidation. So we're seeing consolidation in some greenhouses, especially in Ontario, but across the board, we're seeing smaller farms are being consolidated to become bigger farms at this stage. But does this make it easier to implement technology? Canada by itself, from a global deployment tech market for horticulture, is not big enough. So in a sense that when technology is being built at a mass scale outlook for investors, they want the tech to be available globally. So technology needs to look more global outreach for it to be beneficial for investors to put money into it to become available in Canada. So that's what we're seeing as well. Risks. So risks is everything we think about. That return on investment as part of the risk. Is the technology going to solve the problems? Is it going to cause more problems in the farms or in the greenhouses? So engineers are also, and scientists are starting to look at the aspect of the product development of safety and that part of the risk. So safety in the greenhouses, diseases, right? So that's also part of the risk analysis of deploying technology. These are the aspects of things that we look at as well. This is an interesting graph, and it probably is obvious to you. You know, as labor rates are increasing, the cost of living is going up. We need to pay more. We need to make more money over time. Technology, the cost of technology is going down. This creates an opportunity, obviously, right? So the cost of technology is going down. A cost of an electronic component 20 years ago is much different than today. Same thing with robotics. In other industry, for example, automotive and cars, it's a more prevalent over there. So there's lessons learned that we can take from other industries, parallel industries, to help bring technology into horticulture. So now I'm going to talk a little bit more about the technologies themselves and what's available. So there are mainly five areas that I'm going to kind of highlight. AI, artificial intelligence and machine learning, right? For most people, AI is the most common term. For us engineers, it's nearly the same thing. You need to teach machines to do things, and then they become smarter, right? So we teach the machines, that's machine learning, and then they become intelligent. So for us, it's the same thing. Computer vision, the eyes, how do cameras, how do robots, how do machines identify the fruit, ripeness, can see around them, can see the obstructions. That's a big part of this. Robotics, I'll walk you through the anatomy of a robot. What does a robot consist of? Just like a human being, potentially, at that level. Specialized sensors, the different sensing opportunities that exist or could help, provide more precise abilities in harvesting and other areas of the farm or the greenhouse. And then the Internet of Things. Everything is going to be more and more connected. And that level of connectivity, the questions of data security, what does it mean for you as a grower? What does it mean from a safety point of view if you have your robots connected and doing their own thing? What's going to happen? That's a big part of the formula to think about is how are we going to make sure what we do with that data that's being collected by the robots or the cameras or the other machines. So if you look at technology on a sort of from less complex to more complex, there's obviously the less complex it is, the shorter the return on investment is, the less costly it is. But probably the reason why it's like that is because it doesn't deal with some of the most complex abilities that we as humans can do, which includes harvesting and doing things that are require a lot more complexity to design into a robot, right? Require lower capital investment. They're basic tasks. Typically, one size doesn't fit all, but it can work in different areas, right? These are things like irrigation booms, table systems, and there's a lot more technology on the post-harvesting stage, in distribution, in centers, and after the crop has been picked, how do you put it in boxes and palletizing. So we're seeing a lot of abilities there today, but we'll talk about some technologies that probably exist in the pre-harvesting as well as the harvesting stage included. So let's talk about some basic irrigation technologies. So booms, they're used for propagation, misting applications, and typically those are readily available. They're built within the infrastructure, or you can come install them after, right? There's a mature market for these kind of technologies. Some of them are now, semi-automated or fully automated, or even tap into your climate control systems and do a bit more than that. They're remote, they're autonomous. You don't even have to be there. You can even watch them through screens or even from your phone at this stage. Another piece of technology, this was developed by Vineland. This is part of the funding that created the program. It's a smart irrigation platform. We licensed this technology to a Dutch company, letsgrow.com. That's also parent company is Hugendorn, Americas here, Hugendorn. And this piece of technology, what it does is basically learns from you as the grower on how you want to do your irrigation for your potted plants, for your areas, and then it repeats that process, duplicates that process based on the sensors in the greenhouse, or if you have sensors in the pots themselves, it will do it for you. So this is a machine learning, AI-based technology that looks at the climate inside the greenhouse, learns from you. If you teach it good, it will repeat the same level of learning that it did through your process. And usually you teach it over a cycle, over a full cycle of growing cycle, whether 6 to 8 weeks, depending on the crop, herbs or other crops, and it will just repeat that process again. It also has to be trained in different areas in the greenhouse, so because different areas have different microclimates, so it will take that into account as well. So product handling, I said there's a lot of technologies out there. They tend to be heavy duty. They tend to be readily available, immovable. I want to say less intelligent. There's no need to make them very intelligent, but they do the job to automate. They require a certain level of capital investment to get them installed. So we'll move to the fun part for us, which is the robotics. I was telling one of my colleagues on the table there, I said, part of my presentation, I'm going to have a robot walk out here and say, this is the future farmer, but we're way far from this. Robotics is an interesting space. Most of the time when I travel and I go talk to tech companies and I ask them, how far are you from putting this in a greenhouse? Even for some of the, I guess, more complex but not fully automated robotic capabilities, they're still about 5 years away. So, to be able to have that fully capable robot that can go in and harvest and do the work of a laborer, that's still a long way from here. But there are opportunities to look at certain aspects of basically the harvesting cycle or other, crop management cycles that can be achieved with some of the technologies that are available here. So this is one of the other projects that we're doing in Vineland. We're just finished up. We're in the last stages of the product development. We've established collaboration with both, local companies, but also looking for someone to take it to market and fully develop it. This is a cucumber harvesting robot, right? It was designed for long English high-wire cucumbers, primarily. And the reason why we went for long English high cucumbers, we looked at the opportunity behind a lot of the umbrella greenhouses moving to that space, and the opportunity for the new greenhouses being built that way, and the higher ceiling and the height of the greenhouses. So the business case made sense to start there, but what we learned as we're developing this and testing it and showing some successful results is that from a business case point of view, if you deliver a robot to go and just pick cucumbers, it's not most likely going to work because you need to understand the operations of the greenhouse, the de-leafing aspect of the greenhouse, scheduling, the picking and the harvesting with cucumbers. And not only that, for the business case to be attractive, a robot with that kind of complexity and capability has to have an outlook to do more than just cucumbers. So we started moving towards now harvesting peppers. And that kind of business case, what it does is allows from a payback and a return on investment, once it becomes available, when you're looking at deploying something like this, you can harvest more than one type of crop, you can do more with it, you can do de-leafing, you can schedule it as part of your de-leafing activities and other activities in the greenhouse. So what we're learning, robots have to be built with multi-capabilities in a platform environment for them to make sense. So what does an anatomy of a robot consist of in this case, in this application, right? There are really, at this stage, 5 components, key components for us to develop and to have something out there. And this is what you're going to see when more and more robots are being presented to the industry to be showcased, there's the mobile platform that allows the robot to move, whether it's in a pipe rail, mobile cart, or it's going to be on a basically with a pipe rail environment. So how does the robot move? Even drones. So if they're going to be flying drones in the greenhouses, and we're seeing some applications in that space as well. The other part to this is the manipulator, or we call it the arm. So the arm. So basically, there are technologies out there today, arms that exist, but the business case is still a bit expensive for them. So the cost of that arm, the level of freedom and movement for them, the more it can do, the more it can move, it's a bit more expensive. The business case becomes a little bit challenging. So we're working with companies to say, hey, you need to reduce the complexity of those arms, because when we're doing harvesting, we need to do certain movements, but we don't need that level of complexity, that level of degree of freedom. So these are the things that we're looking at to work with companies to help improve. The other part is the end effector, and this is really like the fingers or what you use at the end to basically either to cut the cucumber or the peppers out of the vine, or to cut the vine or to de-leaf, right? So we call it the end, is the end effector, is the end component in the robot that kind of interacts with the fruit or the vegetable. That's another component. The fourth one, which is very critical, is vision systems. What's exciting about vision systems and cameras is that they've evolved so much, and the hardware themselves are very inexpensive, but a lot of the artificial intelligence and algorithms is really being invested in that space. So a lot of the intellectual property, the complexity, the accuracy, when can you identify the fruit, the speed by which you identify the fruit, the ripeness, what do you do with that data, how do you collect it, there's a lot of capability in that space. And finally, but the most critical to all this, everything needs to come together, needs to work together, and we call that decision systems or decision support systems. So some of us call it the spine for the robot by which everything connects and works together. This is all the way from the brain of the computer to all the separate components to perform the task and then to move at the same time and to bring it back together. So this is mostly software at this stage. Okay, so here's an example of a mobile platform technology, Plantalizer from Automatisation. Some of these platforms today, they do a good job moving around the greenhouse. I was in Green Tech in the Netherlands in the summer, and I probably saw 5 of these platforms out there. So, that technology now is readily available. They have a lot of mobile platforms that are smart. They have GPS location. They can tell you where they are in the greenhouse. The only thing left is to figure out what they can do for you in the greenhouse. So we're seeing some companies looking at UVC, disinfecting, some companies looking at collecting data to bring back so you can know where your potential diseases are in the greenhouse or risks in the greenhouse, or when crops are becoming more and more they're ripe crops, or when to do your harvesting to help you schedule your harvesting. The future in the roadmap of these technologies is basically, can you do more? Can you do crop management? Can you do harvesting? Can you do de-leafing with them? So some of those technologies still, in progress. But something like this, and I'll give an example. I talked to a company out in the Netherlands, and they're saying the payback just for this mobile platform with that is still 5 years. So we're probably talking for something like this, still $100,000. So now, the size of the greenhouse, does it make sense for smaller greenhouses? Obviously, it becomes very challenging at that case. Vision systems. That technology itself, the cameras, the algorithms, the capability, the software, some companies are starting to build databases of ripeness, of growth, of yield. But there's nothing better than your greenhouse, basically making sure that those algorithms work for your environment, your greenhouse, your farm. But there's a lot of technology available in that space where artificial intelligence is being used to basically learn, understand, predict growth, predict yield. So there's a lot of technology available in that space. Harvesting, the lowest hanging fruit, no pun intended, but that one is always the big opportunity. If that's solved, I think we can say we can solve a lot of the labor challenges. There are technologies that are being tested, being validated. There's one here, you can see the green one, the grow harvester from right now offered by Ryder, right? That one was very interesting about that machine. I've seen it in action. I've seen videos of it. It will go collect. It's really designed for smaller tomatoes at this stage. It will cut them. It will package them in that machine. So you don't have to take it away. So it will do it within that big green machine. It will take it off the vine, at the same time package it for you. And there you go. You have now your ready packaged tomatoes. There are technologies that are coming into market that are looking at other crops, but other capabilities within the crops. But that's an interesting one to share. So applications, other applications, as I mentioned, includes, for example, scanning the greenhouse, understanding, the crops itself, the growth on your greenhouse, the risk for diseases, collecting data about potential hotspots in the greenhouse. So right now, there are robots that are being sent into the greenhouse, and they collect all this data and come back to you. Sometimes they don't offer you a solution, but they could customize the solution based on your challenges and your opportunities as well. There's also a robot that is in development by Aruga, the one in the middle in yellow, and that helps you with basically the high wire itself, lowering the high wire. So that's another tedious task that we understand, but that's something that we understand is being developed right now, where it can help you lower the high wire itself. Grafting, so that part of the crop management itself, there are some end effectors being developed for that space, and they're being tested for at this stage in actually greenhouse trials. So now we'll move to the data side of things. So climate computers, I mean, most of you are familiar with a lot of those technologies that exist today in the market, whether it's Priva or Hugendorn or others, Argos as an example. But they're becoming now a bit more smarter. So for example, both Hugendorn and Priva now have developed the sort of the next stage of climate computers, and they developed them with in mind that these robots are going to become part of the future, right? So they want to be able to have the ability to, as they're managing the climate in the greenhouse, at the same time they're communicating with potentially these robots and taking that data that those robots are collecting and bringing back to the computers, and decisions are based on that. So, for example, based on your climate, based on your growth, based on your scheduling, they can tell you, the data that the robot has been collecting. Does it give you actual yield data? Does it the trend line with the activities done on a certain day versus a different time of the year? What makes sense to you? So that way you can pick your best time for harvest or yield as well. Another interesting component to this is they're now being customized for your actual greenhouse, meaning in the sense that you could put your recipes in. They call them recipes. So this is how you want to grow your basically your crops, and based on your knowledge base and based on everything that you're measuring inside the greenhouse, and it will take that knowledge base and it will dissipate it with all the growers inside the greenhouse. Sometimes it's being issued in some of their tablets. So some growers are given tablets, and the data instructions comes through the climate computers. This is another company based out of Vancouver. It's had a lot of presence in Ontario. We've seen a lot of progress. They've deployed some technologies out there. So again, it collects data, looks at diseases, yield. It's available in Ontario as well as in BC. This is a labor, so it's like a smartwatch. Based on the activities of your laborer, it would tell you the movements, it will measure what they do, and you can correlate that back to the activities that they've done. So everything that we've kind of briefly talked about and give you an outlook, what we wanted to do is kind of map it out into where we think in terms of the capital investment versus return on investment. So if you look at the climate computers and those data analytics like the smartwatch, they tend to be on the lower capital investment side, or sometimes a pay-as-you-grow model, right? But the return on investment based on the activities that you need in your greenhouse might be not as prevalent, not as exciting. The other ones are on the other extreme, which is the robotic solutions. We know where a lot of the labor costs are, 30 to 40%, which the data we understand is a lot of the labor costs in harvesting and the crop management side. These are a bit far away. They require a lot of capital investment, but the potential they could have a much higher ROI as well. In the middle, you have the product handling and other technologies that solve different problems in the greenhouse. Another part of this is technology maturity, right? It takes, a lot of people ask the question is, when is this technology going to be available? We see you testing it, we see you researching it, we see you working on it, we see you collaborating about it. It takes a long time, and it takes a long time because a lot of validation steps in the middle to get there, all the way from the ideas created to the research and development, and we're grateful to how much investment is coming in from government and towards these technologies and opportunities. But at the end, we want it to be working. We want it to go to market. So we need a lot more collaboration between different industries, all the way from research and development to product development, to manufacturing, to distributors, to support, to be able to deploy them. And for growers to embrace it, talking to a lot of growers, understanding the needs is that the trust factor, the risk analysis, the validation, they need a lot more validation. Now we're seeing in Ontario a lot of companies collaborating with local grower associations as well as government, and where they're saying, okay, you know what, give us 5 robots for those tech companies, let's test them, right? And that's what they're doing. They're going out and they're testing these robots together. And we're collecting data on them, and then they're able to compare them, and then they're able to understand what does it mean for their own operations. But we see a lot of joint investment to validate those technologies, right? And there could be different business models. So, I was telling a colleague as well that there is, in Ontario right now, there's a company that says, okay, for small greenhouses, I understand you can't afford to buy it. So what I'll do is I'll buy those robots or machines, and I'll lease them out for you. So that's an interesting model. We'll see how that can play out. I understand, is there enough machines to share around, especially in harvesting season? These are the questions that arise, and then the competitive nature of, obviously, the different businesses. But we're seeing that more and more leasing model being available for smaller operations. So coming to a bit to the end, and here, so if you look at what I hoping that you get out of my presentation today, and the research we've done, is that, definitely the high-value crops, tomato and cucumber in your province, we understand the opportunity, but the good news, there's a lot of work being done in terms of product development, in terms of technologies out there. The challenge, a lot of them are startups, a lot of them, right? But we're also seeing a lot of joint ventures. So there's a lot of big companies out in Europe, especially in the Netherlands. They're collaborating, they're forming joint ventures to help de-risk that aspect and buying these startups to help deliver that technology. So small operators, how can small operators take advantage of this tech? We think there could be different business models. Buying it out, right, it's challenging. As I mentioned, the payback on some of those machines are 4 to 5 years. And that's coming from the manufacturer. So, every business case is different. So I think, the leasing model, let's see what it looks like. I think if there's more of that to see what the outcome of that, if it's making sense, I think that could be very interesting for smaller farms. And, basically the robotic aspect of things. I mean, robots they could be the future of helping solve the labor challenge. 5 years away sounds like a long time. Things hopefully improve, but I think more and more validation leads to my fourth point here. My last point is that if there could be more technology validation, and we as Vineland, as an example, are going back to government and saying, hey, you've helped us, you've given us a good amount of money to do research and investment to build the technology, but let's validate it. Let's help de-risk it for the growers and go out and test it on the field and collect data on it and help those hundreds of startups that exist today in the market to validate their technologies for growers so they can see it working. So that level of investment and de-risking from the government is very helpful, and collaboration from the industry as well. And that's just our presentation. And if you have any questions or you want any more information, please feel free to reach out to me. Okay? Thank you very much. Merci.